Okay. Uh, Hi everyone. My name is Hassan. I'm a staff software engineer at Outreach. And if you don't know what Outreach is, we're basically building a platform for uh, automating sales processes. So I recently joined Outreach about 4 months ago as a React engineer. And before that, I was a Flutter engineer for more than 5 years. So today, I'm going to share what I learned after switching from Flutter to React and basically my experience throughout the process. So before we start, do you guys know what Flutter is? Maybe raise some hands. Okay, one, two, okay, a couple of hands. Do you know React? Okay, a lot more hands. That's the main reason why I switched. The second reason was I kind of had to because I was laid off. Anyways, so the agenda for today, we're going to go over my first impressions, so how similar or different React and Flutter are, my first feature, and the struggle of doing my first feature. Then we're going to talk about performance in React and how to find performance issues using profiling. Then we're going to go over some bad practices, some good practices, and then the conclusion and what I learned. So first impressions. Now, of course, before I joined Outreach, even before doing the interview, I started to practice a bit because I haven't used React in more than 5 years. And basically, overall, I think React and Flutter are very, very similar. Like, for example, in Flutter, we have three main types of widgets. We have the stateless widget, which is basically a dumb widget. It takes in some input, let's call them props, and then it renders something like a text or a column or whatever. And then we have a stateful widget, which is similar to a stateless widget. It does take in props, but in addition to that, it can have an internal state. So it could have a counter, for example, and a button. When you click it, it will increment the counter. And we have an inherited widget, which provides some sort of a value. It could be a state, could be a global state on top of the entire application, or it could be a scoped state on top of a certain feature, let's say the login feature or some other feature. And in React terms, stateless widget is basically just a functional component. It's the same concept. You give it some props and it renders something. A stateful widget is a functional component with the help of hooks. So we can have like useState, for example, and then it becomes similar to a stateful widget. And the inherited widget is the exact same thing as context, the context API. So yeah, they are very similar. And also the languages or the syntax of the languages is similar. Flutter uses a language called Dart, and React uses TypeScript most of the times. And like stuff like array iterators, enums, and other stuff are very, very similar. Okay, so my first 2 weeks, it was mostly debugging, finding bugs, fixing small things. I was doing really well. I was very happy with my progress. My team was happy. So yeah, basically that's me after 2 weeks. And then I was assigned my first feature. And yeah, I went from that to crap. I'm a React developer now, and it's very different. So I felt like I went from a senior to a junior because now I'm the one who's asking questions instead of answering questions. Like really, kudos to my colleagues and my team. I was asking lots of questions, and they were supporting me throughout my journey. I was learning GraphQL from scratch. I never used it before, so that was something new for me. And I was trying to use the Flutter techniques that I learned on React, and that didn't translate well. Like, for example, with Flutter, we have all these fancy state management libraries that you can have something equivalent in React, but most of the case you don't want to, because that will increase the bundle size, it will increase the complexity, and so on. So yeah, that didn't translate well. And also, yeah, TypeScript can be frustrating. I don't know, I guess all of you know that. Cool. So show me the code. Now, unfortunately, I can't show you the feature for obvious reasons, but I did prepare something in my free time, which is a feature that is, it's basically a product list with a cart that has, so the feature itself is pretty simple, but it has a complex state because we want to be able to add stuff to the cart from the list, and then also we need to be able to update the cart from here, and then we also need to update the currency in the entire application. So the state itself is a bit complex. And yeah, basically that's the code. We have a hook called use cart products, which is basically just a use state with some callbacks. And we provide these values to like the currency provider or the card provider, and the feature works. It works well. So my first feature, it took me like 2 weeks to develop this like very simple feature, and then I submitted a PR, and then yeah, I got lots of feedback, and basically my colleagues had concerns that my feature might have performance issues. So they told me to do some profiling. So yeah, today we're going to check how we can use React Profiler to detect some performance issues in our app. And then later we're going to see how to fix them. So do you guys know what the profiler is? No? I see 1 or 2 hands. Okay. Okay, so, oh, whoops, sorry. So whoever don't know what it is, I guess we'll figure that out. So to use the profiler, you need to have the React DevTools installed. Most probably, if you're a React developer, you already have it. And then once you install it, you're going to have access to a new tab called the profiler. And in here, we have some settings that we need to enable. So if we click the settings icon, the first setting is under general called highlight updates when a component renders. And then the other setting is under profiler, and it's record why each component rendered while profiling. So we're also going to enable that. So now if with the DevTools open, if we do any updates, we're going to see a bunch of boxes appear on the screen. And these are visual indications of which component re-rendered. And we can see that basically everything is having a box. And the other feature is if we click this record icon here at the top and then do something like, for example, update this and stop, we're going to get some information. This is the default view, but I like to switch to the flame graph here at the top. This will give us a better view. We can move it. So basically, this is showing us all of the components in our app, and we can hover over one of them to see where it is on the left. At the top, we can see that the app re-rendered, the entire app re-rendered, and it took 7.1 milliseconds. And why did it re-render? It's because hook 1 changed. So if you go to the code, basically, I think it means this hook right here. And this is exactly why it re-rendered, because we updated the cart. But yeah, if we look over the app, everything is colored, which means everything re-rendered, with some exceptions here. And to view these small components, we can click on one of the parent components and it will zoom in. And then we can click outside and it will zoom out. Okay, cool. So we did some profiling and we figured out that we have a problem. And the problem is that everything is re-rendering. So why are these components re-rendering? We're going to talk about some bad practices that caused this, and then later we'll see how to fix them. So the first bad practice is what I like to call a global state. So for example, here we have a component called app, and it doesn't have to be app. It could be like login or something. And then we have a state on the top. This could be a custom hook or just use state. And then this component has maybe lots of child components or one or two heavy components in it. And every time we call set state, all these components will re-render. First of all, app will re-render, and that is because the hook changed. And then all these components will re-render because the parent component re-rendered. That's how it works in React. So this is not a good practice. We'll figure out how to fix it in a bit. The second one is that in React, objects are recreated, objects or arrays or functions even, callbacks. So every time this function is called or the component is re-rendered, if we look at the context provider, we're providing an object, a new object, to the context. And this is a very common issue with developers, with React developers, and me when I started. Every time this component will re-render, a new object will be created, so the context will get a new object, and then everything relying on this context will update, even though state and set state might not have changed. So that's another issue. And the second issue is putting everything in one context. Now here we have, let's say it's a to-do application. We have a list of to-do. We have a way to add a to-do, remove a to-do, or mark it as done. So usually, for example, the button or whatever component that is calling add to-do doesn't care about the list of to-dos. So why should it re-render if to-dos changed, for example? And sometimes I see way bigger objects than this. Okay, cool. So these are like the three main. Of course, there are more bad practices, but these are the three main ones. Let's talk about some good practices now, or how to fix these bad practices. So we're gonna go back to my spaghetti code and fix these problems. So here I'm on a branch called v1. If I check out, whoops. Cool. If I check out to v2, we can see that our application now no longer has a state at the top. We no longer have a global state. But where did this state go? So if we go to the card context provider, we can see that the state now lives here in this component, and then everything else is passed to this component using children. So everything we see here, like for example, the product list and the cart are being passed to the card context provider as children. Now, why is this important? Because these components now live inside of app. They don't live inside of card context. So they will not re-render when this hook changes, because they are no longer children of card context provider. They are children of app, or they live in app. So just this one small change will make a huge impact on the performance of our feature. And the second change that I did here is, first of all, memoize the value that we're providing to the context. And the second of all, we split the context into two. One will get the list of card products, and the other one will get something called an API state, which is basically the API, all the methods that will update the state. Now, any component that wants to like remove a product or add a product will not re-render if the list of product changes. So now, just with these two changes, if we go here now, let's clear this. And if we do an update, we can already see that the number of boxes has been reduced a lot. So if we profile and do a change, we can already see a huge difference. So app is no longer being re-rendered. Product list is not being re-rendered. And yeah, overall, there's a huge difference. Now that the re-render of the entire app took 3.1 milliseconds. So here we can see them on top of each other, at the top we have V1, and at the bottom we have V2. So V1 took 9.4 milliseconds to re-render, V2 took only 4.5 milliseconds. Yeah, so basically that is all what's required of me to do my job properly. And this is already amazing. But I think I can do better than that. Especially if we look down here at these small widgets or components. These are the quantities of each, basically of each product in the list. And if I change this, all these quantities will also re-render. We can see them here, product quantity. And that's basically a limitation in context. We can't stop it from re-rendering things even though they didn't change. So yeah, but I think we can do better than that, and we can check out to version 3. So here, what I did is I basically used some of the techniques that I learned from Flutter. And it's basically called reactive programming, where you use things called streams to handle what updates and why, or what re-renders and why. So I created a custom hook called useBehaviorSubject that uses an external package called RxJS. And behaviorSubject is basically a stream, but the only difference between it and the regular stream is that it saves the last event that was emitted by the stream. It just keeps it in memory somewhere. So here we're creating a behavior subject using useState, but we're only using the constructor or the initiator callback of the useState. So we're not doing any setters here. This means that this hook will never update. It will only re-render once, or only render once, and give us a behavior subject that will also never change. Even if we set a value, so even if we change the value of the behavior subject, we emit a new event, the subject itself will never change. And this means when we provide it to the context, if we go back here, we can see that the context was re-rendering. So now it's supposed to not re-render. So how do we consume this? I created something called useObservableState, which basically takes a stream or a behavior subject as an input. And then what it does is it subscribes to that stream. And every time we get a new value, it calls setState. Now, why is this important? Now, only the widget or the component that should re-render will have a state, basically. And then another, like this is just for basically mapping a stream from, let's say, a list of values or a list of card products, and we need to extract the total out of them. It's called piping, which is basically just like a map or a filter. And now if we go to the code, or sorry, to Chrome, let's see the difference. It's basically the same as V2, but if we record what's happening, now we can see the difference. So card context provider, or all the context providers, are now not re-rendering. If we look at the product list styles, for example, this one didn't re-render at all. The only one that did re-render was this one, or no, which one? This one. And only the quantity was changed. Nothing else was re-rendered. Even in the cart, we can see that only this one updated. Yeah, so overall, we can see them side by side here. We have V2, which took 4.5 milliseconds, and then we have V3, which took, if I remember correctly, 1.8 milliseconds. So that's less than half of that. Cool. So yeah, that was all. What did I learn from all of this? The first thing is that React and Flutter are similar, yet they are very different. Like, for example, With Flutter, you're most probably building a mobile application or a desktop application. And you don't really care about, for example, like the bundle size and including third-party plugins. But with React, for example, it's a bit different. You do care about the bundle size because it affects the user experience. Optimize your code as much as necessary. Like as I said, for example, V2 is what's necessary for me to do my job. V3 or using observables is what I would probably do if I'm doing a personal project. So yeah, don't spend 3 or 4 days optimizing one small re-render that's taking 1 millisecond. It's okay to seek help regardless of seniority level. So yeah, don't be scared of that, especially if you're switching technology. However, don't just go to your colleagues for every single thing. Try to do it yourself first and then go ask for help. But it's completely fine to seek help. And switching technologies is not as scary as I thought it was. So yeah, even though I had some issues learning like how to manage the state and everything, overall it was a lot less scary. Yeah, it was easier than I thought it would be. And before we finish this presentation, now is the time to ask any questions if you have questions.